Did you guys do the quiz in the LMS? Yes, no?
Yes, sir.
This is Mandesh saying.
Yes, sir. Good evening, sir.
Okay, Sukena is saying yes. How about Bhagyashri, Mohit? And yeah, that's Rakesh. Rakesh, have you done the quiz?
No, Arpita, I missed that. I will do today.
So, Mohit, did you do the quiz? You can reply in the chat, Mohit. Okay, Bhagyashri says no, sir. Okay, so what we'll do is we will discuss the quiz of the first day. So we are done with the first day curriculum. Today we'll start with the second day curriculum. So we need to discuss the quiz of the first day. Okay, so we'll start with that. So what is the answer for this question? What you see here? Machine with the ability to apply intelligence. Now I want everybody to answer in the chat. So machine with the ability to apply intelligence to any problem rather than just one specific problem, typical meaning at least as smart as a typical human. Which type of AI is being referred here? So A is correct. Okay, not super intelligence. A is correct. Super intelligence is even like way smarter than human beings. So this is right now we are saying at least as smart as a typical human. Okay, but super intelligence is like way more smarter than like the brightest minds on earth, even smarter than that. Even if you club like 100 minds together, but that AI will be smarter. So that's called super intelligence. Okay, so what depicts the best relationship between ML, deep learning, and AI? Among these, what depicts the best relationship? Okay. Okay. So I think all of you are correct. But why is Mohit not replying? Mohit, just put your answer in the chat, Mohit, okay?
Can you hear me?
Your voice is very, very low, Mohit.
Yeah, I'm trying to fix it.
Yeah, just you can, if you have any question, you can then ask me through like audio. Otherwise, you can just reply in the chat.
Yeah, done.
Yeah, no, voice is okay now.
Okay.
Sorry. Okay, so now the next question is, so you need to tell like which option is correct, guys. Just I'll be back, guys. Just give me a minute. So on the left hand side, we have different branches of artificial intelligence. And on the right is their definition. So this is like match the column. So you guys can type your answers in the chat. So we have 4 options here actually. Let me reduce the size of the question a little bit. Now I think you guys can see the entire question. So has everybody answered? Sukena says C. So, okay. Second. Okay. So it's correct, guys. C is correct. Oh, Sukena says it's A. No, Sukena, it's not A. It is C. C is correct. Right. If you have any questions, guys, then let me know. Otherwise, I'll keep continuing. Okay. So, like, if you want any explanation, then let me know. Otherwise, this is like self-explanatory. C is the correct answer. Okay. So here. Okay, now answer the question, guys. Like below is a lead scoring dataset. Choose the option that reflects the correct machine learning terminologies. So what is what called? Okay, Mohit says B. Mantesh, why C? B is correct. B, Sugena, correct. Mahendesh, why C?
So green is the target label, no, sir?
No.
Feature.
So actually this should have been red. Otherwise, all these greens are like features. And this is the target label. Label or target, you could call it anything.
So, but converted, not converted are features, right?
No,
Label.
those are
Okay.
classes. Converted, not converted are classes.
Yeah.
Okay. So Mantesh, you always get confused here only. So you
Yes,
need
sir.
to get this right in your mind.
Got it.
Fix it.
Sure, sir.
Okay. So an unlabeled example contains features but not the label. Below is a lead scoring dataset which excludes the target conversion status. The below dataset contains unlabeled example. So is this statement true or false?
True.
Okay, so Mandesh and Bhageshri says true. How about Mohit? Sukena? True. So, right, guys, this is true because we don't have the conversion status. So this is like unlabeled, right? Okay, now most common unsupervised machine learning tasks are classification and regression. So is this true or false?
False.
Okay, false. Why is this false?
There are other models too.
There are other models. Okay, correct, Mahandesh. Mahandesh is correct. Guys, regression and classification falls under which type of learning?
Predictive.
Yeah, it is predictive. That's branch of AI. But if I talk about like which machine learning, which kind of machine learning it is. So it is like Mahendesh is writing, it is supervised
Super,
machine learning.
supervised. And it
Okay,
can
so
be
right now,
unsupervised also.
no,
Classification.
no, unsupervised examples could be clustering, segmentation,
Mhm.
but classification and regression fall under supervised learning. Okay, so this is false. Okay, Bhageshwari. how many features should you pick when you first start a machine learning project? So how many features should you pick? Okay, Mohit and Bhageshri says C. So correct. I think everybody said C, right? Okay. Right. So C is absolutely correct. 1 to 3 features that seem to have strong predictive powers. Should you collect data and look for correlations before defining the ML problem? Yes or no?
No.
Okay, Mahendesh, I'll explain question number 8. But first try to answer. Everybody try to answer. Should you collect data and look for correlations before defining your ML problem? So Bhageshri and Rakesh says and Sugena says yes. Mohit says no. So B is correct, guys. No is correct. Because if you've not defined your ML problem, why will you even collect data? And why will you even look for correlations? So what is correlation? Like
The
in
relation.
previous, so basically correlation in simple terms are like whether the features that you are taking, are they very, very like, do they have strong correlation with the target that you're predicting? Okay, so like the other day we discussed, shoes beauty is not a very good feature. It does not have like a very good correlation with whether the person will buy the shoe or not, when we took that example, right? So but before you even like, the first step in making your machine learning model is defining the ML problem, then you get to data collection and finding correlations and stuff. But first is you define the problem. Yeah, so Mohit says when A influences B, so that's also a good definition. So like what he's trying to say is like, if you have a feature A, so does that have an influence on your target, what you want to predict, and how much influence does it have? So remember in the last class when we were doing clustering, and Tarun mentioned about standard deviation. So there he was mentioning that, a couple of features like the income level and the spending score had the lowest standard deviation. So that proved that, they have the highest correlation also. So something, on those terms. Mandesh, did you understand the 8th question?
No, sir. If you don't mind, can you explain once again, sir, please, for last time?
So, so Mahendesh, it is very simple. See what is defining. Can anybody give me examples of how to define a ML problem? Remember, we did a flowchart in the machine learning class. Anybody can write it in the chat. I even showed you a table of type of ML problems. That's the first step. Do you guys remember any kind of ML problem? Very simple, guys. We are talking about it. Right now only we've said those words. Is anybody typing? So we spoke about classification, regression, clustering. These are all ML problems. Within classification, you have multi-class single label, multi-class multi-label. Within regression, you have unidimensional regression, and you have multi-dimensional regression when you predict two numbers. So these are the kind of ML problems. Remember? Yeah, so within classification, you have binary classification or multi-class classification. Within multi-class, you have multi-class single label and multi-class multi-label.
Multi-level.
right? So before you define this, first you need to define, like you are doing regression or classification. Inside classification, what kind of classification you are doing, or you're doing clustering. So you need to define the ML problem and then look for collecting data and then go for correlations. Mahendesh, did you
Got it.
understand?
Perfectly got it, sir. Thank you very much.
Okay. So next question is, suppose you want to develop a supervised machine learning model to predict sales. Which of the following statements are true? Okay, Sukena says B. Mahantesh says A and Bhageshri says B. Rakesh, what do you say? Okay, so B is correct, guys. Now, can anybody explain why is C not correct?
Because we are talking about supervised model and here it is unlabeled example.
Very good. Also, Mahesh, why did you think A was correct?
So because I thought in that when we are creating an ad copy, we usually give the target. Uh, at the ad word bottom, sir, call to action. I thought that could be used as a target label. Click here, sign up. I got
Mahesh?
confused there.
No, but now do you understand that this is not a good feature? Ad copy words in ad copy will not make a good label,
Yes, sir.
because the label that we are predicting is sales number. It will be a number. It will
Correct.
not be words in the ad copy,
Right.
right? So
Right.
because we are doing a sales forecasting model, no?
Right. Right.
Okay.
Yeah.
Then for subscription based businesses, retaining customer is of utmost importance. Suppose you want to build a supervised machine learning model to predict customer churn. You want to predict a label for each customer as delighted, satisfied, likely to churn, and will churn. What will be the problem statement for this model? So tell me. Okay, Sukena says C. Mohandesh says C. That's okay, Rakesh. If your internet is slow, that's okay. Mohit says D. Bhageshwari says C. Okay, so C is correct, guys. So can anybody explain, Mohit, why is D not correct?
Sir, can you hear me?
Yeah, we can hear you.
Yeah. Sir, I was thinking that because it's a different customer, so it will be multi-class and multi-level, individual to the customers or subscription. So I have that.
But did you understand now that why is D not correct?
No, sir.
Because, so anybody else, Bhageshwari, would you like to try, or Mahandesh or Sukena, would you like to try?
Sir, in this model, okay, if anybody wants to try, let them, sir. If nobody, then I'll take my turn.
Okay, Mahandesh. Bhageshwari, do you want to try? Okay, Bhageshwari is not replying. So, okay, Mahandesh, go ahead.
Here in machine learning, the problem is we have to predict customer churn. So it is single problem which we are predicting, sir.
Right. So, we are assigning a single label to each customer. Right, Mohit? So that's why it is called, even though we have multi-class, like multiple classes like delighted, satisfied, likely to churn, will churn, but we are assigning a single label to each customer. We are not assigning multiple labels to each customer.
So what would be the example of multi-level?
So example could be, let's say if you have built a model which will classify blogs. So it is possible that you might assign multiple categories to a same blog. A same blog might fall under, let's say, digital marketing and also SEO.
Right.
Okay. So, and let's say or else you've built a computer vision classification model in which you are showing, let's say 10, like an image in which there are 10 different animals, and you want the model to predict all the 10 animals. So then you're assigning 10
Different
labels to a
labels.
single image. So it
Right.
is multi-class, multi-label.
Okay. Got it.
Okay. Okay, now let's go to the next. Suppose so this we did like similar thing we did in the class, but let's do it. Suppose an online store wants to create a supervised ML model that will provide personalized shoe recommendations to users. That is, the model will recommend certain pairs of shoes to Marty and different pairs of shoes to Janet. The system will use past user behavior data to generate training data. Which of the following statements are true? So they want to make a recommendation engine. So Sukena and Bhagishri says B and C. Mohit says D and C. Mahantesh?
Sir, I am confused, so don't want to take a chance, sir. I don't know.
So basically, see, suppose an online store wants to create a supervised ML model which will provide personalized shoe recommendations. That is, the model will recommend certain pairs of shoes. Basically, it's a shoe recommendation model, okay? The system will use past user behavior data to generate training data. Okay, so it will use user behavior data. Now, can you track whether a shoe is adored by, somebody, or some shoe beauty is a useful feature? Beauty is in the eye of the, person who's looking at it. Some people find something beautiful, some people find something beautiful. So you cannot really track this, and you cannot even track shoes that a user adores is a useful feature, is a useful label, sorry. But you can track all these things. A user clicked on the shoe description and shoe size is a useful feature.
Got it.
Okay,
Thank
so
you. Yeah.
B and C are correct. Okay. Suppose you want to segment your customers on the basis of shared psychological characteristics. What will be the problem statement of your machine learning model? Okay, Bhageshri says C. Mohit says B. Mahantesh says A. Sukena, I'm not sure. Okay. So, suppose you want to segment your customers. So we did segmentation in the last class. We did cluster analysis in the last class, right? So the problem statement will be clustering. It is unsupervised. Just told you so many times. Like today also we've discussed this, right? So Mohit is right. And Mahandesh, you should have been right in this. Why is this binary classification? You are segmenting customers. You know this. It is called clustering. Right, Mahandesh? Okay, so guys, now whatever questions are coming up, they're actually for day 2. So now the quiz is over actually for day 1. Now we'll continue with the day 2 curriculum, okay? So first thing that we want to do today is called AI for Marketing Playbook. Okay, so this is basically like a cheat sheet in which I've listed down all the AI goals possible, which I've identified so far. I'll keep adding more in this, but whatever I've identified so far, all these goals I've added. So you can see these goals. So what do we mean by goals? These are, you can even think of them like different services that you can offer to your clients, or different things that you can achieve using artificial intelligence for marketing. So you can achieve a lot of things using artificial intelligence, but here we've only mentioned about marketing things that you can do using AI, right? So for each goal that you want to achieve, I've told you which kind of learning will it be. Will it be supervised or unsupervised learning? So which ML approach will you have to take, supervised or unsupervised? Which technique will you use, like classification or regression or clustering? And which algorithms are not important, because we will use automated tools, and I will add actually a column here of which automated tool can help you do this, like without code. But for now we've also mentioned algorithms. Okay, and I've covered all the branches of AI. So predictive analytics, these are things related to predictive analytics. These are things related to natural language processing. Okay, these are things related to computer vision, and these are some things related to recommender systems. So these are basically some 20 odd things that you can do in marketing when it comes to like using artificial intelligence. Okay, so let's discuss them a little more. So like, if in predictive analytics, what kind of things can you do? Predict customer churn. So see, actually, you can predict like anything. So if I keep mentioning, what all can you predict? So there'll be some 100 things I can write, because when it comes to like predicting ad campaign performance, so you could predict like CPL, CPA, CTR. I hope you guys know all this. So CPL is cost per lead, CPA is cost per acquisition, CTR is click through rate. You could predict placements. So, but I've mentioned the most different kind of things and the most used things in marketing. So predict customer churn, will the user recommend your product, and lead scoring. Okay, Mantesh, you have a question, go on.
Sir, you said CTR and other stuffs we can predict. For example, now if we have to predict some models, we have a standard Excel format which has to be in CSV format, correct? That is the base.
Right.
But once we have to predict CTR or what will be the campaign results, what data we need, sir, there?
Same data, your ad data.
Only the ad part we have to give it, sir.
Yeah, so you can download an Excel sheet from your Facebook campaign or from your Google AdWords campaign.
Sir, at the end or maybe at the end of the course or last week, can you show an example for Facebook or Google AdWords campaign, how it can be done?
Yeah, I can show it to you.
Thank you, sir.
So will the user recommend your product, lead scoring? So these are all classification techniques, because you are classifying customers, will they churn or will they recommend or not? Will they subscribe or not? Kind of things can also come here. And two very popular algorithms for supervised learning is, logistic regression. And actually, I'm sorry, guys, regression will not come here. Random forest is a very good algorithm. Regression will actually come here. So I will correct this. Okay, because regression is used for predicting values, right? Classification is not used for predicting values. So some values that you can predict using AI is like predict sales, optimize product pricing, predict customer lifetime value, programmatic media buying, predict marketing mix, right? So these are some kind of things that you can use. If you guys don't understand like any of these terms, then please ask me. Or if you don't understand why are they important also to predict, so then also you can ask me. Like, do you guys understand what is programmatic media buying? What is predict marketing mix? So Bhageshri, you understand what is programmatic media buying? Yes, no? Media buying. Okay. So see, I'll tell you a little bit about it. So let's say, basically you can do like simulations. So media buying is, the amount of money you will spend on a particular platform. So you decide, like, if you're doing Facebook ads, so how much money will you spend? If you're doing Google ads, so let's say if you're doing Google ads, now, you know how Google optimizes itself is through, let's say if Google showed your ad to 1,000 people, okay? Out of those 1,000 people, 500 people clicked on your ad. Out of these 500 people, let's say 50 people converted. So they bought your product or your service. So you will have like 500 people here who did not even click on the ad. And you will have 450 people here who clicked on the ad but did not buy the product. Okay. So first, Google, what it will do is it will look the characteristics of these 50 people. So it will look things like age, gender, location, browser. Look, it could look at things like device, internet service provider, then query. Query is basically what did he write on Google. Then Google could look things like interest, hobbies, what time of the day, what season of the day, what day of the week. All these things, Google will look. So next time when somebody, comes on Google and, they write your keyword on Google, so Google will increase your bid so that your ad shows up on the top. Okay. So because see what happens on Google is you pay for each click that somebody does on your ad. You pay for each click on Google. So there are 7 spots on Google, right? If you have ever seen on Google, you see 4 ads on the top, then there are 10 organic results, and you see 3 ads at the bottom. So Google will keep fluctuating your position of the ad. So this is called like media buying. Okay, depending on the person who's come on Google and is searching for your product or service. So if people who match these 50 people come, so Google will increase your bid so that your ad shows up at the top in the first 3. Okay, if these kind of people come who click but did not convert, so Google will probably show my ad on the 4th position or on the 5th position. And if these kind of people come who don't even click my ad, so Google will probably show my ad on 6th and 7th number position, because you don't want to waste too much money on acquiring such people who don't even click the ad. You want to spend your highest marketing budget on these kind of people. So whenever they come, Google will increase my budget and show my ad on the top. So these kind of simulations as well you can do from machine learning. Okay, so if you, but actually what happens is Google can do it better than you, because you will not have access to data in real time. Only Google will have data in real time, and it can only fluctuate your positions. But still, like these days I am doing a course about Facebook machine learning, so wherein basically they are using machine learning for optimizing Facebook campaigns. So such kind of simulations they are doing there. Like if you change the Facebook placement, so placement is if you show your ads on stories, or if you show your ads on feed, or if you show it on right column, or if you show it on audience network or in messenger. So these are different places where you can advertise on Facebook. So how will it affect your other numbers like CPA, CPL? How will it affect this? So these are like simulations, that campaign simulations that you can do using machine learning. So something like that is media buying. Okay, so then if I talk about unsupervised learning, okay, Mahantesh, ask one question.
Sir, now that 1,000 which you mentioned initially is impressions, right?
Yeah.
And now, sir, I don't know, I mean, whether this question is relevant or not. You can shout at me if I'm wrong. Sir, now, if 50 people who have clicked, and next time Google will identify the similar people who have clicked and our ad appears on top, that is understood. Then what's the use of bidding, sir? Even my competition, if he is doing the same thing and he's increasing the bid, so what the bidding plays vital role here? I hope you got my question, sir. And third thing is, sir, whenever you are starting that Facebook ML course, no, sir, kindly let us know.
Okay. I right now I'm doing the course. If I start, then I'll let you know. Okay.
Okay, sir.
So see your
But was my
first.
question relevant, sir? Second question.
I'm not very sure what you're trying to ask, but what I'm explaining you is called automated bidding. And
Okay,
there's something called manual bidding. So manual bidding is when you tell Google that I want to pay, let's say 150 rupees for each click. So then your ad position is static. Then your ad will just remain on probably 2, 3, 1, wherever it comes, depending on 150 rupees, wherever it comes, it will only remain there. But this is not a good strategy because you should keep fluctuating your bid depending on the person who's come on Google. So if he's a relevant person, then you should increase your bid. If he's not a relevant person, you should decrease your bid.
got it, sir. Thank you very much, sir.
Okay. So clustering we were doing in the last class, right? Behavioral segmentation, psychographic segmentation. We were actually doing kind of like demographic segmentation in the last class because we had data like, age, gender, annual income, spending scores. So these are like demographics. And we were using this algorithm, right? K-means algorithm. So that's here. Then you also have something called market basket analysis, which is a technique called association rule learning, which is used in building recommendation engines. Okay, guys. So for making recommendation engines, you need to do unsupervised learning. Why I'm saying this? Why? Because see, understand like how do okay, now let's come to recommender systems. So then you will understand better. So see, there is two types of recommendations that can be made. If you mix these two, then there could be like a third type of recommendation engine. But generally, like basic principle is these two kind of recommender systems that I mentioned here. So one is called collaborative user behavior, and the other one is called content similarities. So when you do especially content similarities, this is like market basket analysis. Okay, this is unsupervised. So like if you go on YouTube and you watch a certain kind of videos, so YouTube will suggest you more such kind of videos. Okay, so there YouTube is doing this kind of recommendation engines, which is called based on content similarities. Okay, so you make a clustering model wherein you, let's say if you have 1,000 books and somebody has read one book. Now what you would want to do is you would want to recommend them similar books, right? What he's read one, and if he's like that book, so you would want him to know more about such books. So if you have 1,000 books, you can cluster them into, let's say, 10 categories or 20 categories, or depends. uh, till the time your model quality is good, you can create like multiple clusters. But basically you will do cluster analysis to find which books are similar in content wise, so that if somebody likes one of those books, you can recommend them other books also which are in the same cluster, which have content similarities. This was clear, guys? Was this example clear?
Yes, sir.
Right. And another kind of recommendation engines are based on user behavior. So what is user behavior? Uh, so basically the machine will learn the pattern of different users and then recommend based on that. So let me give you an example. Like if I talk about YouTube. So if you watch, let's say if I watch videos related to let's say basketball. Okay. And then I also start watching videos related to, let's say, football. Okay. So, and if a lot of people do this, if Google is recognizing the same pattern, same user behavior, that people who first start watching basketball videos also after some time also start watching football videos. Okay, so now what Google will do is, if somebody else is watching basketball videos, it will recommend them football videos automatically, because it knows that that's the user behavior. That's what in general people are doing. Okay, so yeah, like when you go on Amazon.com, on the product checkout page, you see a section called "Somebody who bought this also bought this." Right? So that is basically a user behavior kind of a recommendation engine, that they are analyzing somebody else's behavior and making recommendations to you based on, in general user behavior. So when you do this, this is called supervised learning. And when you do content similarities, so that's like clustering kind of thing that you have to do. So that's called unsupervised. That falls under unsupervised learning. So these are some algorithms, but right now actually for making recommender systems, like like if you talk about Google, IBM, Microsoft, and Amazon, you need to code. Okay, but there are some other tools that you could use and make recommendation systems very easily. Like I'll show you a tool called Morphle. So see, this is like one tool called Morphle. The AI platform for e-commerce personalization. So if you check out their services, and guys, these are the kind of services like, nobody is right now offering in India. And we can definitely like, tap into this market as well. So if I click on solutions e-commerce, so I'll show you like what all things are they offering. Products, machine learning models. Yeah, so see, shopping stage. So basically users that are more likely to add a product to cart, go to checkout, or complete a transaction. So it will basically predict which shopping stage they are in. Okay. Cart abandonment, users that are more likely to abandon their cart in the current or next session. So this will predict, who's more likely to abandon the cart. Customer LTV, this we've already discussed. CLV, you can calculate. Now see, recommendation engines. Personalized product recommendations that suit your customers' taste and preferences. And you don't have to code anything. You just have to connect your Google Analytics account. This could be your Google Analytics 360 if you have. This is like a paid tool, but and if you have like a Shopify store or even a WordPress store, so you just need to connect your Google Analytics and your Shopify or WordPress, and you can make like a recommendation, a section which will start recommending people. Yes, Bhagishri, you can integrate this in Shopify stores. And I think it is not also very expensive. So this costs you around, I think $150, which is around 10,000 rupees. So if you're doing like, little bit amount of sales, then 10,000 is not that much, because recommendation engines are proven to increase your revenue by like mostly like on an average around 20%. Okay. All right. So coming back here, then natural language processing. So some things that you can do that fall under natural language processing are reveal customer psychographics, right? So this we will do in the class. We will use a tool called IBM Personality Insights. That's the 4-day curriculum. wherein you can, use IBM Personality Insights to reveal somebody's psychographics, so somebody's personality, and based on that personality, IBM will suggest you consumption preferences also, like what kind of music this person will like, or what kind of movie this will like, or what kind of automobile or what kind of clothes this person will buy. Okay, so also a lot of other things as well. So if you guys know, the best test for detecting personality is called the Big Five model, and IBM, uses the Big Five model. So we will discuss about the Big Five model when we get there. But yeah, it's like one of the best personality predicting models. So there are also tools like Crystal Nose, CRYSTAL, which use IBM Personality Insights in the backend to reveal the personality of LinkedIn profiles. So Crystal knows, see if I just show it to you. Actually, my trial is over with Crystal knows. So I'll only be able to show you their website, but you guys can check it out. Like they have a Chrome extension. I might have it. I might have it. I'll have to check it, but I think I have it. Okay, this is actually a new laptop. So, but see, what you can do is see like this. When you go on any LinkedIn profile and you click on their extension, so they show you like what kind of personality he falls into. Like, is he an influencer, or is he a follower, or is he a leader? Such kind of things, and what kind of subject lines you can send them. Uh, a lot of things. So check this out. It's a very, very cool tool, and it uses IBM Personality Insights in the backend to to make those predictions basically about personality. Competition analysis, trend analysis, sentiment analysis. So this I think I can cover in like an extra class. Right now, this I'm not covering actually sentiment analysis, but it is actually very easy to do sentiment analysis, and you don't need any code also for it. So I can take like an extra class and I'll tell you about how to do, sentiment analysis, or not really sure about trend analysis and competition analysis. But if you have the data, see, competition depends on a lot of things. Like, if are you checking SEO competition, or Facebook ads competition, or Amazon product, competition. So depends on a lot of these things, and accordingly you can build a model which can, do some kind of analysis for you. But okay, I will definitely find some data set to do sentiment analysis for you guys. Okay. Then under unsupervised learnings, things like creating a voice bot, telephony, voice search, and chatbot. So all these things fall under unsupervised learning. We don't have to, really get into what algorithms they use, because I can tell you how to create a chatbot, like an AI-based chatbot using IBM Watson, and you don't have to code anything in that. But good to know information is that, it is unsupervised learning, and these are some things that fall under NLP, and we can do it through, AI for marketing. Even I was able to create a voice bot as well using IBM Watson. uh, but it does not have like a use case in my business, but yeah, for some businesses it can definitely be a very good thing to implement. Then unsupervised deep learning. uh, so this is basically, now we're talking about computer vision. So create images and videos. So the other day somebody else was telling me that there is a tool for creating images and videos, but like with Google, or with these, tech giants, Google, Microsoft, I'm pretty sure that you cannot do it without code right now. You need an algorithm called GANs, which you could only do it through code. But some other kind of, like, there's a tool which is like a meme generator, AI based meme generator. It will generate memes, right? There is so some tools are like this there, but if you have to do it from scratch, then you have to code. And let me do some research on this as well, actually, and let me find some tools through which we can, create images and videos as well. Then generate all text or images, generate textual description or of images. So this is useful for websites like who publish a lot of content on daily basis, like CNN or BBC or BuzzFeed or Daily Mail, right? These are like big content houses which produce like 50 blogs, 100 blogs in a day. So what in each blog, they have like 5 images, 4 images. So if you guys know what is alt text, you should basically generate alt text for images. So alt text is you make Google understand that what is that image about. Okay, so Google cannot see, it can only read. So through alt text, you tell Google that what an image is about. Generate textual description of images. So another example of this is like I use an app called Tagwag, Tagwag. So if you put any picture in Tagwag, it will generate a relevant social media caption that you can share on social media with that image. Okay, so now they are doing that using again, same thing only, that basically the computer vision model will first understand what the image is about and then use NLP to, generate a relevant social media caption as well. And you can also use it for your blogs or for your website. Visual social listening is basically you detecting logos, and this we will do in the class. You can make a model which can detect logos. Okay, so it is good for brands to basically monitor that what people are talking about themselves, about their brand on social media through images. So earlier, how brands did sentiment analysis is through text, but now you can analyze images as well, that what they are sharing through images by detecting their logos. Otherwise you will, like, brands like to count mentions, like how many people have mentioned them, right? But if they mention them through images, so they used to miss it. But now you can even count logos as well. Implement visual search engine. So this also we will do in the day 4, wherein you will basically know how to find similar images. So what this is, visual search engine, uh, basically if somebody comes on your website and drops an image, so your website should show similar images. Okay, now if you're an e-commerce store, it will show similar products. If you're a website like Shutterstock or iStock, then it will show similar images, right? So this we will learn how to do. Your AI goal, use visual data for personalization. So visual data for personalization is, guys, basically like you can create a machine learning model which will personalize based on visual data. Like if I talk about, like, let's say Lenskart. So Lenskart can make a model wherein it could be trained on telling that which sunglass will look the best on a particular face. So what kind of features it can consider? So it can actually consider skin complexion, it can consider beard, hairstyle, it can consider shape of the face, and some other things as well, right? So if you consider all these things, and based on that you predict that which kind of sunglass will look the best on somebody's face. I know this is a little subjective, because beauty is again in the beauty is subjective. It is, you cannot really quantify it, but yes, you can at least make some recommendations, because for a fact that long faces, generally these kind of sunglasses look better. Round faces, generally these kind of sunglasses look better. So on that basis you can definitely make a model. So that's called visual data for personalization. Okay, so any questions with this, guys? Yes, no, any questions? Okay, so now from next class we will actually do practical, and we will build a leading model in the next class. But we have one more topic before that, and it's called the blueprint. So this blueprint is, guys, like, your plan about your project, AI project that you will do. So you should plan it very well, right? So here is an example of like a company who is trying to make a recommender system. Okay, so these are some questions that you should answer about, your AI project that you're trying to build. And this blueprint, you can also present it to your management, you can present it to your clients before you execute for them, because it will give you a lot of clarity. It will also help you decide whether your project that you're trying to do has a clear use case, whether it will be valuable for the business, or it will not be a value for the business, right? So things like that. So first you tell, like, what is your AI goal? What is it that you want to achieve with AI? Like improve user engagement, build a chatbot, create a recommender system, or predict an outcome. Refer AI marketing. So roadmap is like playbook to see some potential marketing goals. So here, this company is writing, the goal is to provide product recommendations to the user based on purchase decisions of other users. So they're trying to make a collaborative recommendation engine, right? The goal is to increase sales by upselling and cross-selling based on purchase behavior of other users. So, that's basically their AI goal, upselling and cross-selling by providing recommendations. So the problem statement is that at present, we do not recommend products to our users, which is impacting our sales and other engagement metrics. So you don't see like most of the e-commerce companies are not recommending right now, but they should recommend, and that is impacting their sales. Solution: build a product recommendation system that will recommend products based on what users frequently bought together. This will help increase sales and improve engagement metrics. So like Amazon has a section frequently bought together. So here again, these guys are trying to make a model in which they will see the user behavior, that which kind of products do user generally buy together. And based on that, they will make the recommendation. Potential challenges. So you have to list possible blockers for your AI project, like skill upgradation, project funding, availability of data, etc. So train the model on new data regularly, as the fashion trends are always changing. So yeah, so this is also a challenge. You need to train the model on regular basis. Otherwise, your model might not be very accurate. Especially if you're in fashion and stuff, then you have to train it regularly. So next column is value proposition. How does your AI project add value in the growth of organization? For example, a new AI powered product to generate revenue, or improving an existing process to cut cost. Okay, so what's the value proposition? So here they say generate revenue by upselling and cross-selling products. Product recommendations will help improve engagement and micro conversions. So micro conversions are like for e-commerce, where the macro conversion, the final conversion is sales, but micro conversions would be like add to cart, or clicked on a product, or added to wish list, right? So these kind of things are like micro conversions. Then stakeholders, list the key stakeholders. Okay, something in chat. Yeah, Mahendesh.
Sir, with respect to value proposition, now if we are going to launch a new product which is not come in market at all, it's a new product. That can that be treated as a value? Proposition where we can, and is it possible for us to predict the sales of the new product through AI?
See, everything is possible. Your data should be correct. Do you have the data to predict the sales? If you have the data, then yes, you can
And
predict
what
sales.
what what could be the data for new products, sir, which is not yet launched?
So you need to do market research for that,
Oh,
competition research, market research. See other competitors, basically how much are they selling, demand, supply, weather, season, all these kind of things.
got it.
Okay, so stakeholders. List the key stakeholders that will be involved in your AI project. For example, UI team, legal team, management team, vendors, etc. So in this case, UX team, marketing team, and development team are the stakeholders which will be involved in the project. Then the fourth stage, fourth column is data. That what do you need? So identify data that your ML model should use. For example, transactional data, engagement data, historical campaign data, demographic and psychographic data, etc. So in this case, they need past transactional data, which is available in any CMS. Like if you have Shopify or if you have WordPress, so transactional data is available. And if you're doing proper e-commerce tracking in Google Analytics, so there also it'll be available. And user demographic data is also generally available through Google Analytics. Also, if you run campaigns on Facebook and Google, so they will also give you some demographic data. Or else you can do some surveys also to collect the demographic data. What data is already available? Mention the data that is already available at the moment. So past transactional data is already available, okay? How will you acquire the unavailable data? For example, create a data pipeline by tracking user activity or from a third party, or conduct user surveys and interviews. So demographic data can be collected through questionnaire. Encourage users to fill out the questionnaire by offering a discount coupon. So if you don't have demographics data, then you can do some kind of surveys and you might give some, discount coupons to motivate people to fill the survey. Output. What output would you like the ML model to produce? A number, a label, a cluster, or something else? Similarity index between users and recommended items. So see guys, since we are doing, clustering here, this is, since we are doing, collaborative user behavior, which is, clustering, so we need to calculate the similarity index. So if you remember in the previous class, in each cluster, how clusters are created, that, those clusters have like a closer similarity index, right? So here basically what our model will do is that it will analyze that what kind of products do people generally buy together, okay? And does that person have a similarity with the person who's right now browsing the website or not? So see, similarity index between users also you need to calculate here. So let's say if, like, Mohit and I are similar, okay, in terms of, let's say, demographics and interest, hobbies, let's say things like that. And if I've come on Amazon or any other website and I bought a product A and then I bought product B as well. So when Mohit comes, so that website will recommend, and if Mohit buys, let's say, A, so that website should recommend B as well, because our similarity index is very, very like close. So, that's what is basically we're trying to do here. Now, model requirements. So define your ML problem. So this is, we discussed this today also. Define your ML problem. For example, you're doing a binary classification or a unidimensional regression, multi-class, single label, or clustering. So here they say association rule learning, infer likely association patterns in data. So that's the problem, because I told you, like, clustering for recommendation engines is known as association rule learning. Skills required is mention the skills required to execute your AI project. For example, NLP, computer vision, deep learning. So here clustering, Python, and data engineering is required. So data engineering is basically like for collecting data and for transforming data, you might need, data engineers. Algorithms. So mention which algorithm will you use. So k-means and matrix factorization. K-means will be for clustering, and I think matrix factorization will be for similarity index of users. Then test. Now this is a very important column. Now what you'll do here, guys, is, you need to define your model metrics and your outcome metrics. So these are different metrics, like your model metrics are different, your outcome metrics are different. So outcome metrics is basically whatever model you're building, how will it have an impact on your business? What kind of impact, on what metrics it will have an impact? So let's say if you're doing a recommendation engine, so it should improve sales, right? So here we write like revenue, okay? But what is a model metric? So for each kind of, ML problem, like for binary classification or regression, you have some metrics. You need to, in the next class, we'll do them in very detail. Like one of the metrics for, like one of the metrics is RMSC, recall, precision. So this basically tells the accuracy of the machine learning model itself, like how good is the model predicting or how bad is the model predicting. Okay, so these metrics are as per the model accuracy, but these are the outcome metrics. These are like what impact it will have on the business. Okay, so these are different metrics. This you will understand better in tomorrow's class. I mean next class. Then conclude whether you are happy or not with the model performance, whether you will go ahead and deploy the model in real world. So basically, once you train the model, after that you conclude whether you will use this model or not, whether you will deploy it in the real world or you will not use it. You might have to retrain it, you might have to change certain things and retrain it. We are happy with the model performance as RMSC is low while precision and recall are high. So right now I'll not get into what is RMSC, precision and recall. We'll do this in the next class. We will deploy the model. So the next column is of integration and adoption. Describe how you will integrate your project into the current infrastructure for stakeholders and for customers. Also explain how will you train others in the organization so they understand and keep up with the project. So, integration is basically we intend to create a new section on every product page, which will recommend products under the heading people who bought this product also bought. So integration is basically you tell that where will the model look, where will people be able to see the model, where will you integrate in your website or in your CRM, or where will you integrate it? Okay, where will your employees or your customers, where will they see the model? So that's integration. And adoption is train, like how will the team adopt to it? Train a developer or a marketer to know how to train and test the model. So that's simple adoption. And then finally you do cost and revenue. So you do estimate your expenditure for executing this project. For example, data cost, compute cost, salaries. So discount coupon cost was one cost because they might have to do surveys. Compute cost is basically what Google or Amazon or whichever company you are using for making the model will charge you. Okay. Additional salary for data engineers because they had to hire engineers. So this is all their cost. You should actually put numbers here, but right now I'm just giving you examples here. Revenue, estimate how your AI project will enable company to get new income. Will the project reduce internal costs through automating processes or support an innovative initiative? So, basically you tell in terms of numbers that how much will be the new income that will be produced, or will it cut, if it will cut cost also. So that's also basically kind of a revenue that you will generate. Okay, so that's about it. You have a printable version of this as well. So you can download it from the LMS in case you have to use it. Like one of my students in my first batch called Kapil. So he is actually trying to build a prediction model for his company. So he's filled it up. All of these columns, he's filled it up. Even Salahuddin. So you were asking me today question about pricing, that price prediction model that you want to make. So I'll suggest that follow all these steps, like fill up this blueprint. So you'll have a better understanding of your pricing prediction model. And in the next class, actually next to next class, we will do sales forecasting. So if you follow all those steps, then you will be able to do your pricing prediction also. So Salahuddin, are you here? Okay, but he is attending the class though. So that's all, guys. Any questions?
Sir, by default, so we can take this as a thumb rule. The minimum data set should be of 1,000 rows, irrespective of the model you do, irrespective of anything you do, not less than 1,000 rows. And it
Yeah,
should be in
otherwise
CSV
Google,
format.
yeah, otherwise Google will not accept your Excel sheet only. Yeah, it's a thumb rule. You can count it as a thumb rule.
And 30% positive
Yeah,
results.
that is not a thumb rule, but that is like a very important guideline that your model should have like 30% minimum positive and negative. Like both should be, no, none of the class should be like less than 30%.
Okay.
Salahuddin, are you here? Okay, anybody else has any other questions?
So you said I'll show the prediction, CTR prediction for Facebook.
Yeah. So how to do that?
Yeah.
Okay, so what I'll do is I'll do an extra class, and probably in that extra class I can show it to you. So I'm also actually learning it in, I know like I can make a prediction model that's there, but they are using some other tool actually for it. And their course is also okay, not very great actually, but I'll share some insights from that course with you guys also.
Yes.
Hello,
Any
sir.
other? I'm
Sorry, I
sorry.
was Salahuddin with you.
Yeah, hi Salahuddin. So Salahuddin, what I'm saying is that fill up this blueprint for your price prediction model. Okay,
Okay.
fill up this blueprint. You will have better idea about how to make your model. In the next class, we will do lead scoring, and after that, we will do sales forecasting. So when we do sales forecasting, it is same, like almost same like what you have to do. If you follow all those steps that I show you in the class, you can do it with me only. If you follow all those steps, you will be able to make your model.
Yes, sure, sure.
Okay.
Yeah, this Excel sheet is available where in LMS.
Which Excel sheet? Are you talking about this blueprint?
Print.
Yeah, blueprint is available. You can download it. Or else you can just like, you know, you don't have to necessarily like fill it in the blueprint. Just answer these questions in a Word document. Anyhow, just answer these questions. You should answer it. You will have better clarity, and you can then present it to your management also.
Okay.
Okay. Any other questions, guys? Okay, so I think we don't have any other questions. So next class is full on practical. You guys will need a credit card in the next class. Okay, so make sure you have a credit card. I will also suggest you guys can watch self-paced videos in the LMS about how to create accounts with Google. It's very simple. You just have to actually go on. See, I'll show you. You just have to go on cloud. I'll suggest do it like before the class. Just create your accounts with your credit cards. Just go to cloud.google.com, and right now it tells me go to console because I'm already logged in and I have an account, but it will tell you guys, okay, let me go incognito. Your credit card won't get charged. Okay, so see, it says get started for free. Google is giving you $300 credit. Okay, so right now I'll have to log in and everything, but it is basically you just have to put your credit card, it won't get charged. Yeah, Mandesh, you can tell me.
Sir, can I just wanted to show you one Excel sheet, sir.
Okay. Share your screen.
Yeah. Can you see my screen?
Yeah.
Yeah, I'm just opening that. Sir, now why it is coming in? I had to open this in CSV format.
Doesn't matter. You can do that later on. Right now, just show it to me in the notepad only.
Yeah. So these are around 1,400 data which have taken from 2018 to 2020 October 1st. These are some of the discontinued orders now, which we have discontinued. So
Right.
when I predict a model, these are only discontinued. There are no three parameters like last time. One lost, discontinued. In discontinued, how many orders should I reactivate? What are the chances where I can win a order which is discontinued? It is possible, no, sir, to create a model for this?
No. Do you have the data set of wherein you show that out of discontinue, how many have, continued? How many you were able to convert out of discontinued? Do you have that data set?
No, I have like one column, a target label column which shows one lost and discontinued.
Show me the target column.
Yeah, it was like this, sir. I've just segregated this sheet here. The status is one, then you have one lost and discontinued. You have three status here.
In this Excel sheet itself.
No, no, there is one more Excel sheet, sir. I will download it tomorrow. Like it will have like this one lost, discontinued. If I have like this,
Yeah,
if I have like this, is
then
it possible for me to understand in which suppose this is discontinued, can I retarget this customer?
no, instead of retarget, you should predict which kind of customer will you win, which will you lose, and which will be discontinued.
But that already I have, sir, here. That status is already there. So my question was in discontinued, because we have neither one, neither lost, we have discontinued. So if I want to target these cases again, is it possible if I have this target column?
But do you have data set like people who were discontinued? Were you able to target them and get some good results? And do you have that data set in the past? Have you done that?
This is the data only, sir. It is in the
No,
past.
no, then you cannot do it.
Mm-hmm.
How will you do it? Anybody else has any ideas? Please share. Uh, so, but why don't you want to predict the status
So
of the
can I?
new leads that will come in?
Okay, but okay, that we can do, sir.
Yeah, that you can do.
Then I will just download the leads where opportunities there. Got it. I will download that sheet
Because
and keep.
then you will only focus on people that you can win, no? Then you can
Got it, sir.
not focus on lost and discontinued
Okay.
kind of people.
Okay, I will download that sheet and keep it ready in the next class. I will try to work with you parallelly. Let me
Sure.
see.
Sure. Try to build it, like if you can, try to build it before that also. But
Yeah,
otherwise, we can definitely try to make it parallelly.
sure, sir. So in that this column will not be there. It's as simple as that.
When you train it, then yes, it will not be there.
Yeah. Got it, sir.
Yeah.
Thank you, sir.
Okay. Any other questions, guys?
We can create lifetime value of the customer through this data. Can we?
Mohit, what are you saying?
I'm saying, can we create from this particular data, what would be the lifetime value of a customer? Because there is too much of, discontinuity.
So I need to see the data again. So do you have their transactional data, Mahantesh? Like how much have they spent with your website or with your business over the years? Do you have that data in the Excel sheet?
Then we can backtrack that thing, and I'm just assuming.
So Mahantesh, do you have any transactional data in the Excel sheet?
Means what transactional data, sir? Quotations.
No, yeah. So when you say won, so how much business did you do? Like how much money did you guys make?
Yes, sir. That data is there.
Yeah. So then you can calculate customer lifetime value also, and you can predict CLV also.
Okay. But sir, here one more question. Now the sheet which I showed you,
Yeah.
one lost, discontinued, that is actual results. The previous one which I'm going to download are the leads. These are opportunities. So in leads, whether it is a lead or not, I'll just download, sir. Let me do my homework. Then I'll ask you proper questions, sir.
Sure. Sure. But the feature columns, see, I think the problem that you'll face is the feature columns that you showed me like last time were different. The headings, the column headings were different. So that should not be the case.
Okay. Okay.
So you download all the sheets, then we can analyze.
Sure, sir.
Okay, guys, any other questions? Sukena, any question? Are you thinking to build anything, Sukena? Any possibility?
Not yet. We're not building a data model right now.
Okay. All right.
So not yet.
Okay. All right, guys. So let's call it a day then, and let's meet on Thursday, same time. Okay. Try to please create your Google Cloud accounts and finish your quiz 2 also in the LMS. Okay.
Thank you, sir. Thank you, everyone.
All right. Yeah. Bye.
Yes.
Bye.